Welcome everyone to a follow-up of last month's shoutout here of an AMD Zen 2 and 3 YMM register state rollback bug. A quick summary, otherwise video live stream from a month ago. Tavis Ormandy from I usually Google Zero and Project Zero, I guess, found a bug that affects, they initially speculated Zen 1 and 2, but I found also Zen 3 CPUs that's very specific, frequent use of the X-saves instruction of all the X-save modern massive register, vector register save instructions. There's X-save, X-save C, I believe compressed, and X-saves S with secure hypervisor state, as far as I remember. And so to summarize that, so that is easily triggerable, right? And theoretically AMD said, so there are multiple things broken here. Not only there was the belief in this thread, by the way, the state of Linux kernel and security and stuff, it's like, yeah, 2023 can't even read the more nicely formatted archive at lkml.org because infrastructure, security and stuff apparently hard, right? And so they, at the Linux kernel, they were discussing this here, and so while the initial people discussed this, also I believe probably from SUSE or so, other people also like, yeah, investigating, clarifying with AMD. So the saying was also, so this is an unknown errata from AMD, and in this Linux kernel mailing list thread was mentioned, there's supposed, like, this errata should have been fixed with microcode, yet even on this Ryzen 5950X, I can reproduce this, right? And so there's also, I would say there are many people at fault, of course mostly AMD, of releasing a buggy processor microcode and not shipping fixed microcode. Also previous video, there is not even, like, unlike Intel, which yes, they have maybe more bugs, but they at least have microcode updates. For all those CPUs that I have, there is not even a microcode update from AMD. Why AMD? If you have erratas and you fix the microcode, give all your users microcode, right? So if we want to reproduce this, hammer and secret. So this is 5950X. Also, Tavis Ormandy found this with Threadripper 3000 Zen 2 plus or whatever. And so while they were still discussing here, like, yeah, maybe this, maybe waiting, AMD appears to have screwed up there, and we figured and stuff. So someone else, like entirely unrelated, right, of this, you see here Tavis Ormandy and Borislav Petkov, and okay, to be fair, there was Andrew Cooper already, but anyway, so why this was being still discussed, I believe Andrew Cooper went ahead from Citrix, like, yeah, let's patch that here, right? So the problem with that is, this patch is garbage. I'm really sorry to say this, and also with the title of the YouTube video, usually the Linux kernel developers like Linus Torvalds and Greg Hartman, many other, Alan Cox and all the other famous people in between, they're usually for decades known to speak frank and blame everyone else, like Intel's bugs, AMD bugs, NVIDIA, it's like finger, right, not proper open source support, right? And usually Linux kernel, everyone else is at fault, right? Microsoft shitty SMB protocols or CIF not documenting CIF, and obviously right? Intel sucks, AMD sucks, NVIDIA sucks, Microsoft obviously sucks the most, right? But the Linux kernel developers don't really do better, right? So this was completely not communicated here, and half as, like, totally, so this is, it was clear that, I believe, even in the discussion, I mean, I should have replied, right? I just not subscribe to LKML and but it was still here, like, let's figure, like, working on it, stay tuned, right? Although not sure if they're currently working at AMD or SUSE, I lost overview. But so yeah, we need a table of all Zen 2 parts. Also, like, by the way, yeah, I should chime in there, but hey, you need to share, like, subscribe, but I can't reply to each freaking email, right? I can also, like one single extra code company here in Berlin can also not do the research and security for all the big mega corporations, right? It's like, also have other stuff to do here. And I can't hold the hand of each patch there and stuff. And this is such, like, I want to outline, and this is just one example, right? It often happens. I often review stuff and I sit there like, dude, what were they thinking? They blame everyone else, but they themselves produce the most half-assed non-working patches. So super trivial patch, right? Alan Cooper here, also if you're wondering how they work at Citrix, that is probably how. It's like only compile tested. It's like, yes, security and stability of leaking YMM state and stability and stuff. It's like compile tested. It's like you had one freaking job, right? Compile tested. That, like, if you see this in a freaking email, that probably says all. This once backporting to all stable trees that understand Xsafe, but before needs Xsafe C support. So like, it's only freaking compile tested, but hey, let's backport it to all stable trees, although it's only compile tested. Anyway, so this was like, yeah, that's not the right function. There was some minimal discussion. Any reasons for rushing this? Or like, yeah, this Boris, like, any reason for rushing this, not waiting for me clarifying affected models first. It's like, yeah, this is exactly like people like, hey, wait, stop. This is like half-ass shit here, right? And when even at this point, I made a YouTube video of like, hey, Sen3 is also affected by me. They probably want to share, like, and subscribe. But so anyway, then there was a discussion like, why? Well, yes, more reports impacted systems. Yeah, but like more report of affected systems, but you only freaking patch half of them, right? And that's also the dangerous thing. There's multiple things here. So it's super dangerous because there is no continuation in this discussion, right? I sit here and wonder, like dude, that is not finished, right? But as far as I know, the last email is already like some 20 days old. And that is the dangerous thing. So not only now you have a half working screwed patch out there. It's like, hey, affected systems, yeah, but only half of them, right? And now nobody cares anymore, but hey, bug fixed. It's like, no, it's not freaking fixed, right? And also, hey, it's compile tested. Amazing. And it's also like, well, having the full list of affected models is great and all, but how does it going to change this patch as a workaround? It's like, yeah, we don't have to clear the freaking flag for those systems. And also maybe they are freaking more affected, which was known at the time already. And what was even the last email here? Whatever. So, as you see, this is still affected, right? So, what have I done? Also, probably I should have, that is no, wait a second. Just had to mount some encrypted file system. So I fixed this now better. So what is the problem with this, right? So they, I would also in general say, so not only maybe like fully tested and not only compile tested, also work with AMD. So the root cause is AMD, right? AMD is it's a responsibility similar to Intel. And I would like to really, why do I make this video? I really want to promote, similar to Louis Rossmann, to help companies more responsible. Because Intel and AMD, and certainly other companies, they release hardware that is defective, right? That is not working fully or error-free and stuff. And I understand that, right? It's billions of transistors and stuff and complex instruction set architecture. But if you have bugs and security issues, then provide these updates. And since decades they have this means of microcode patches. So it's AMD's fault, first and foremost, to release microcode, which they barely do, which is not very serious. And secondly, this patch is also, ironically, Greg Krohatman had here talk, like CVEs are dead, long live the CVEs, like disclaimer, yada yada, CV is bad and doesn't work well and stuff, and it's like, yeah, and so on, setlib CV for this and that. And also, I'm really not a fan that the Linux kernel does not include CVEs in changes usually. So I find this like, they say like CVE sucks is like, yeah, it's better than nothing, because what we get in the Linux kernel is basically nothing. And this stuff should actually have some CVE and some kind of CVE. And if CVE sucks, then make it better, but not none. And because what happens, you know, there is no common identifier to track this. That's what, when you're not having CVE, then you don't have this common identifier to track this. Similar to, I often don't know what is fixed in the Linux kernel, because for 95% or so, they don't include, like, they, the Linux kernel upstream developers, because yeah, CVE sucks and stuff, you're not working like that. It's like, yeah, thank you very much. No, we have like, instead of 59%, at least some identification. Although I would say the vast majority of bugs don't even have a CVE at all, like zero, none, because like stuff is like YOLO'd in between the coffee break and the end of the workday and stuff. Cheers. And weekend developers. And so then we don't have an ID to track it at all. And so how to, I mean, there are two things, right? I mean, the first thing is rushing this here and not including all known variants. And I show you in a second. So actually the patch that really made it in there was, did I not click on the right one? Oh, darn. This is when I believe this should, yeah. So, yeah. So this was the second version, which like, initially they said, yeah, why have it in the common sen? Actually, maybe that was even buggy. Wait a second, let me check that here. Where's the bloody patch? This is not the patch. Init. Yeah, okay. So initially they had this in this init AMD sen, also in my opinion this abbreviation, but they had this in this init AMD sen function, and then later I'm not sure if someone complained or they voluntarily moved it over to that. Well, let's maybe check that. They moved it to another, ironically they moved it to another function, and so this is already bad style in my opinion. They have here some init spectral chicken, which is some other errata, and I would even say that that was already not the super most ideal, because I would not mix different, like if you have one workaround function, then it should only do one workaround, and not like this AMD spectral, also like amazing naming and stuff, right? And bugs and more bugs and hashtag peak bugs. So this is a spectral check-in thing here, and only if config CPU unread entry sent to offer this chicken bits on the altar of speculation. And so in my opinion, if I would have been Linus Torvalds, I would not have applied it like this. Probably he didn't even apply it personally. It was probably part of some stable in x86 and whatever. I mean, it's not like he's reading all those millions of lines of code every month. But in my opinion, bad style, right? So they moved it here, which is not ideal. And so the reason they moved it in there is like, why check for model 17 hex when we have already a model 17 only function? But this is only, I mean, not only is this bug not only model 17, because it's also, spoiler alert, model 19 hex, right? But again, also, like, look at this, right? All the metric init AMD K5, 6, 7, 8, GH, LN, BD, Bulldozer, Jaguar, whatever. It's like spectral chicken. It's like seriously. Anyway, so I of course moved this now because I like my data centers, cloud servers, customers, and my own workstations bug-free and register state not corrupting. I moved this now in this sen function where they had it to begin with, and then also like if it's x86 before 19, so they had, if you compare this here, they had this, okay, in this is implicit, that is 17 as far as I remember. Initially they had this, yeah, 17, but again we have seen it affects more, right? It affects model 19, but for 19 it's even my Ryzen 7000 is also family 19, which is a little bit annoying. The way the CPU ID works is in general a little bit annoying for x86 due to the complex and convoluted history, because initially they had some bits here and then they extended that, I believe. This is why this bits needs to be shifted and OR together, because we have here stepping model, family ID, extended model and stuff, so you need to OR, although they write here add, but that means of poor man's description of OR, shift and OR extended model and model together. And so this is why I had this here open. So I checked here CPU ID here of other people. So that is a little bit nah. Somehow there are really many models in this family. So unfortunately, all of those here are model family 19 hex. Then whatever 3. Yeah, it's even written here, family 25, 19 hex. So all Zen 3 and stuff. So the only thing here is, okay, that is an engineering sample anyway. So we need to be a little bit tricky and careful here. And of course, I can't be sure whether this is a complete list, but if you want to be my AMD contact watching there, drop me a note. Happy to work together with more people inside AMD. But yeah, as long as they don't have a complete list and I don't have a complete list, at least my affected systems. So what I've seen is Zen 4 is not affected, Zen 3 is affected, and I have here some 2 whatever, 21 hex. I can't be sure about those ones, I don't have them, but I better deny list them as well. I better mask them as well. In general, I would say this way to work, this is of course the easy way. I would even say, so what this does is it simply clears the CPU capability, right? It's just masking 1 bit out there in this CPU capabilities, the X-save as bit. So I check here for family 19 hex and model less than 60. 60 is in general, here you see here 60, so that's not what I have. I have, I believe, 70 something, I believe, so I would hope all Zen 4 are fixed. Time will show. But last but not least, this is sure, it is a high performance and simple way of like, hey, if it's this x86 CPU, let's mask it away. But of course, this does not take account into, is there an updated microcode? Like maybe in some months AMD comes out with finally doing the right thing and shipping microcode to all of us in Linux firmware tree. And in general, instead of us guessing, right? So the better thing in general, no matter whether there ever will be an AMD microcode update, would be to functional test it, right? Some other stuff is functional tested, like this bloody spectral chicken here, I believe. So that is here read save CPUs and read save, and this value is not this spectral chicken bit there, then whatever the spectral chicken does, I probably should read this bloody errata. But other stuff, even from good old K6 or whatever days, so some other stuff is testing here, whatever, re-enable topology extension. So the right thing probably would be to try to reproduce this in kernel space. This test code is rather simple. I just don't, so normally I would suggest to actually test the CPU if it happens with that one. It might be tricky in kernel space. This code was this one. Do we have a Vim highlighting? Somewhat. So I just don't know how much stuff. I don't want to spend now hours. Kernel developers, Linux kernel developers would know better. As I don't know what triggered that, I would guess maybe loading this, loading that and then xsave as might be enough, I don't know. The problem is, of course, that the Linux kernel, so I don't know if a syscall is required, right? I don't know how many other instructions like a system call or whatever needs to be in there to actually cause this bug. Maybe it's in there. So if a syscall is necessary, or something like that sort, but maybe it isn't, maybe, yeah, whatever. That's of course difficult in the Linux kernel, right? If that would be a microkernel, it would actually be kind of easier. You could then in a microkernel user space simply run this. In the Linux kernel, it is not impossible, but certainly significantly more trickier to do some context switch with flushing enough state and whatnot necessary to trigger this YMM register rollback aim debug. But yeah, I would in general, so because it is potentially not trivial and I don't want to waste many more hours of my time, and the Linux kernel style is not calling for that, right? I'm just pointing out that, in my opinion, functional testing for all those bugs should in general be preferable than simply checking some CPU family and masking it for all of that, no matter whether some microcode update is installed or not. But anyway, that's it for the summary. I hope you enjoyed this and learned something. I'm pretty disappointed how, like, really currently, right? It's not the first, like constantly bugs are handled in strange ways, in incomplete ways. And instead of handling stuff better, they only present like, yeah, CVE sucks and stuff, and long live CVE. Anyway, we're not using it the most, but YOLO? I don't know what the takeaways. I should also say in general, I said this multiple times, but last but not least, in my opinion, they have too much random changes in the stable trees. I said this the other day, live on more Code Therapy live channel. A lot of stable stuff is not security, not other stability and stuff. It's, I would classify it as like nice to have, but not really stable versi. Here, PowerPC, replace obscure, never production stuff. It's like, yeah, sure, but you had a decade for that, and you realize now, and you pushed in stable, like, why? It's not like people compile PowerPC 64 every other day with E5500. It's like, why? Also, disable unknown CPUs for Clang. It's like, next to nobody is using Clang to build the Linux kernel anyway. Like, why is this unstable, right? Instead of focusing of doing the security and bug and corruption mitigations and stuff, right? It's like, why waste your time with all this, like, not all, like, probably kind of half, maybe, or it's like chips, frame buffer, fix error codes for, although this, yeah, I mean, sure, maybe that is not the worst thing in stable. I'm only pointing out often many things I scroll over here. It's like you had years, and it's not like security or stability and stuff. It's like why is it in here? Similar to the other day, we found here some frame buffer stuff. HPPA risk, STIFB. Frame buffer, STIFB provide valid pixel clock. I believe that it's probably not stability. That's probably just you don't have frame buffer output or not the right mode. And that for Hewlett-Packard precision architecture with very few people, like only Helge Delaire and some Debian fans and I run or stuff, like for the 12 people on the planet who is still running Linux on a Hewlett-Packard precision architecture, it's nice to have. Sure, it should be in the next kernel release, but why the heck is that unstable? But your Zen 3 has state corruption. Anyway, that's it for this video. I hope you enjoyed this and learned something. Whether it's the first time you see x86 assembly code or that there are bugs. All right, we wanted to test this. So, yeah, right. So this, I actually, I have this patch, right? I can also show you the patch. So last but not least, T2 will be the first Linux distribution who will have this mitigated for Zen 3. The patch looks like this. I believe I saved it already. That would be hotfix AMD or something of x86 AMD xsaves. Moving that out of there. The same code here, but for all other new modern Zen variants until, oh wait, did I probably meant less than 60. So model, so either less than family 19 hex or 19 hex and less than 60 hex. One last fix there. And then kexec, this good stuff. Kexec 628 fixed. That's better. So this system does not yet have that in the init, so that is only recently. Let's re-execute quickly. That is of course without like kernel directly executing the new kernel without going through the BIOS and stuff for significantly reduced reboot times. Obviously, previous video, best invention since sliced bread. So let's CPU. We killed the tasks. Let's see, one hammer and yeah. So that's mitigated. That is working as expected. As usual, looking forward to your comments. I guess I have to send comments and patches to the Linux kernel mailing list. Thanks for sharing, liking, and subscribing. Patreon, GoFundMe, because I'm a little bit busy working after LVM Clang, Rust, Mesa, Linux kernel, breakage, every day and night here for 25 years because somehow too many things are broken, hashtag peak bugs, and so on. Maybe a quick comment here to the one last check here. Zen 3 Plus affected. My understanding is, so the Stream Deck is affected. My Ryzen 3950X, 5950X and Steam Deck are affected. So yeah, I don't know which is the first CPU or microcode that fixed that, but my Ryzen 7950X is not affected. Last but not least, comments there would also prefer more testing, stable branches, and even more LTS. And they also say PSR panel self refresh to be disabled, the scatter gather stuff, and it's like question, will it ever go upstream? Yeah, I will send it in. Actually, I wanted like already 2 days ago. I wanted to reply there, but because like 20 years ago I was subscribed to Linux kernel, but it just became too much, and for me it's mostly pointless because people usually disagree, right? So oftentimes I had hard time to get stuff in anyway because not doing it like that and don't like that and stuff, and it's like let's please rewrite like that, and who cares about Spark and stuff, and like YOLO, whatever, then do what you want. I wanted actually to reply to this email and like beside gateway timed out, I downloaded the mailing list archive here for that. Actually, I wanted to reply. I mean, obviously you should reply to this thread, and I didn't instantly got it to injected this raw email into my Emacs Mu client to reply to this email 2 days ago, and then it was like my lunch break was over, and it's like But I should obviously, because it is quite some significant YMM register state corruption. So yeah, later tonight or so, with some wine at home, when I brought the child to bed and stuff, then I probably fill the raw email into my Emacs Mu and reply to that and point out that it's still half fixed. And also, yeah, I said it before in the last email, maybe write to your local AMD representative and ask for microcode update, because in my opinion, they should be fixed in the microcode, right? If you have x86 instructions and they don't work as advertised and don't save the correct register state, then my opinion is that it's a serious enough bug that should be freaking fixed, right? And not like, let's just not use this function because it's freaking broken. It's like, yeah, it would be amazing if the advertised CPU features actually also freaking worked here. But yeah, don't forget to share, like, and subscribe, YouTube membership, Patreon, GitHub, sponsorship and stuff. And I hope you learned something. have a good day and night, and see you soon. Yeah, link you could give is to this email, right? If you want to write to your local AMD representative that, as usual, if I answer some questions, I put it in the comments. It's maybe like the whole thread starts somewhere like this one. So there you have it. I probably should pin it below in the comments. See you soon.